Hi, and welcome back to another Leetcode video. We're looking at Leetcode 1716, calculate money in Leetcode Bank. It's an easy problem, and in this video we're going to approach it interview style, which means we are going to apply a systematic approach to solve the problem that involves clear communication, and we're going to focus on the problem solving aspect of things and really just going through a rigorous process that'll lead us to a solution. So the goal is really not to just write the code as fast as we can, but to practice a systematic approach. And part of that is first to understand the problem. So yeah, let's just dive into it. So Percy wants to save money for his first car. He puts money in the Leetcode Bank every day. He starts by putting in $1 on Monday, the first day. Every day from Tuesday to Sunday, he will put in $1 more than the previous day. On subsequent Mondays, he'll put in $1 more than the previous Monday. Given n, return the total amount of money he will have in the Leetcode Bank after the end of the nth day. Okay, so that means, so we're going to have to, well, since it's an easy problem, the first assumption is that we're just going to implement exactly this process as if we are simulating the whole process. With many of these easy Leetcode problems, there's also a closed form, but in an interview, coming up with a closed formula might sometimes be too much. The easiest way is to just try to implement exactly what is written down here, implement it as a simulation. And what you'll end up with is, of course, here, since we have n days, we will probably have to iterate over all of these days. So we'll have a linear time solution, O of n solution. And we probably get away with O of 1 space for the result. And we need to memorize how much money we put in the day before and how much money we put in the Monday before. And yeah, so that's currently what I'm thinking about how we should approach this problem. Now, in an interview, you would also ask about what are the constraints for the inputs and what does the input exactly look like. You would ask if n is always going to be a positive integer, or can it be 0, for example. You would ask all of those edge cases. Is there maybe an upper bound to it? Because if there were, you know, everything would automatically be O of 1 space and time. So that would change your complexity analysis at the end. And you'd also want to know what is the exact return format. Now here on Leetcode, you're giving all of these type hints, and you can kind of guess what the input is, but you should always clarify that, no matter how dumb you think that is. Clarification really helps you to avoid running into dead ends later because of wrong assumptions. So, okay. So let's look at the constraints. So here we are told that we are at least going to invest money 1 day. So n is at least going to be 1. And there's actually an upper bound to n as well. But for the sake of complex analysis, we're just going to ignore that there is actually an upper bound. But it's a good hint that our simulation is going to be a feasible implementation because we don't have to worry about very large numbers of n. Right, so after understanding the problem, clarifying the input and the output format, the next step would be to come up with some examples. And you can ask the interviewer to give you some examples, or you can come up with some on your own. You know, it's a good idea to, you know, engage with the interviewer to collaborate on solving the problem. Now here on Leetcode, we're giving, of course, the examples, and example 1 is input n equals 4. So that means we're going to invest money in 1 week, right? So on the first day, we're going to invest $1. You should write that down here. So on Monday, we invest $1. Then comes, this is day 1, 2, 3, 4. Right, this is going to be our n. So on the first day, we invest $1, and then every subsequent day from Tuesday to Sunday, we will invest $1 more than the day before. So we'll invest $2 on the second day, $3 on the third, and $4 on the fifth day. And then the sum is going to be, what is it? Well, that's 10, right? 1 and 2 is 3, plus 3 is 6, plus 4 is 10. Right, so the output would be 10. Okay, let's look at the next input. So the next input is 10. So that means we're actually going to invest over more than 1 week. So we're going to have to apply the second rule as well. On subsequent Mondays, we'll put in $1 more than the previous Monday. So let's just let's write this example as well. So we have 5, 6, 7, 8, and the 10th day, right? This is our n, and we will invest. Well, I should write Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, Monday, Tuesday, Wednesday. Right. So between Tuesday and Sunday, we will invest $1 more than the previous day. So on Friday, we invest 5, Saturday 6, Sunday 7. Now comes the Monday. And on the Monday, we invest $1 more than the previous Monday, which would be 2. And now the whole investment mechanics start again. So now invest 3 on the Tuesday because we invest $1 more than on Monday, and 4 more. So what we'll get here is we'll get the sum of all of these elements, which apparently is 37. Yeah, and here you can see that it's summing up all of these elements. And then for the second week, it's 2, 3, and 4 that gets added. Right, so yeah, that is basically the algorithm. And by now, it should be kind of clear of how you would implement that simulation. You could also start to think about maybe, what is the pattern when I invest multiple weeks? You know, maybe there's a closed form that is easy to attain. So the investment would look something like this. This is the week, the first week. In the second week, it's the same, but everything increased by $1, right? And by the third week, and that's going to be what our investment schedule is going to look like. And so now if you had a value of n, you would have to determine how many weeks you invest. You know, and you can sum up these numbers. Maybe we should do that actually. So what do we have here? We said 1 plus 2 plus 3 plus 4, that's 10. Plus 5 plus 6, that's 21. So that would be 28 in total, right? Now in the second week, it's exactly the same as the first week plus all the days of the week. So it's going to be 28 plus 7, right? That's what it's going to be, because we basically have, this is going to be 27 plus 8. So that's 28 plus 7, which is exactly this. And then in the fourth week, we have that plus 7 times 2, right? Wait, yeah, plus 7. And plus another 7, yeah, plus 2. So 1 times 7, 2 times 7, this would be 2 times for the first week. So now you could ask, okay, how much is that when we add all of these up, right? And by the way, maybe you notice that 28 is 4 times 7. 4 times 7, right? So we could probably write this as 6 times 7, the third week, and the week before is 5 and 4 times 7. So yeah, and if we express it as the week number, we would say week number plus 3 times 7 is what we invest in week W. That's what we would invest. And now you could continue and find a formula to adding up all of these sums so that you can compute how much you invested up until that week. And then you only have to continue to simulate maybe the next week. So you could find a closed form for the first couple of weeks and then simulate just the last week. That would actually give you an O of 1 time solution and also O of 1 space. But I'll leave that up to you. I'm just going to implement the simulation approach. And for that, we said it's going to be O of n time and O of 1 space. Oops. O of 1 space. And yeah, we're going to have a result variable. By the way, I'm jumping into an implementation right now, which I shouldn't have done. Normally, after analyzing the problem, you talk to the interviewer, say, hey, I see 2 approaches. I could continue this, exploring this to find a closed form, or I could implement the other one. Would it be okay if I just implement the first one? And whichever you prefer, you could just suggest it and ask, whether you should implement it, and the interviewer says yes, and then you start implementing. But you don't jump into the implementation without asking. Right, so we're going to need a result variable, right? And that's what we will return at the end. And that's going to represent how much money we've invested in the bank, right? Now, we also need to keep track how much money we invested the previous Monday, right? And we need, Monday. And we need to keep track of how much money we invested the previous day. Because remember, we need to increase our investment by $1 compared to the day before. So the next thing we'll do is we just iterate over all of the days that we're going to invest. Now we have to check, okay, what day is today? Is it Monday? Is it not a Monday? So let's check. What do we do when it's Monday? Well, and let's say the Monday is the day at index 0, 714, etc. So if that is a Monday, we will say, well, how much money invest on a Monday is how much money we invested on the previous Monday plus 1, right? We'll put in $1 more than the previous Monday. So we could say Monday 1. And this is perfect because we initialize it with 0. So the first time we encounter Monday, we know we're going to invest Monday money. So, and we have to increase our result. And we have to set our yesterday variable, right? That's also Monday. Right, and then we continue our loop iteration. So the next time it's Tuesday, it's not Monday anymore. So we have another case here. Well, if it's Tuesday, we said we're going to invest $1 more than the previous day. So that's yesterday plus 1. And then we also have to increase our yesterday value by 1 because we know we invested 1 more. And we can just write it like so. And that is everything we need. And as you can see, so if we go through the first example, n equals 4. By the way, this is now the next step in the interview. After you wrote your code, you want to step through it with a mental debugger to spot any issues that you might have introduced, like syntax errors or logic errors. And the best way to detect them is to take one of the examples from earlier in the interview and just use that to walk through your code and explain what is happening. So that way you're forced to express exactly what the logic is. And because you understood what your intention were with the implementation, you will very easily spot issues with your code. So that's highly recommended. You never want to just hit submit or anything and then end up in a debugging session where you go silent and the interviewer doesn't know what you're doing. So let's use N4 as an example to step through the code. So we start, so we initialize all our variables with 0. We start with I as being 0. The value of Monday becomes 1. So it becomes, comment. That's it. So the value of Monday is now 1. And maybe I'll write what I is. So I is equal to 0. Monday is 1. Our result is going to be 1 as well. And remember, yesterday is 1 as well. Cool. Now I becomes the value 1, right? Because in the range from 0 to 4. So now it's 1. We don't hit this branch anymore, but we now go to this branch. So yesterday gets increased by 1. So it becomes 2. And results gets increased by that value 2. So our result value is now 3. Cool. Next iteration, I is now 2. Again, the first part of the if statement doesn't catch because it's not a Monday. We end up in this branch again. Now we're increasing the value of yesterday to 3, and we're going to add that value to our result, which is 6. Right? It's exactly that. So we have now 1, 2, plus 3. Check. Yes. And now, well, our I becomes, wait a second, 1, 2, 3. No, yeah, I is 2, right? We were at I1. And now we're already, we just concluded I equals 2. So now we go for the last time in the for loop with I equals 3. And it's not a Monday, but it's a weekday. So what we do is we increase yesterday by 4 and we add that to our result. So it's 10 and then we return the value 10. So that's pretty much how that would work. Now you could, also go through another example if you wanted to. I find it a little bit tedious for the easy problem to do that. But if in doubt, just ask the interviewer, would you like me to go through the other example? So I'm fairly confident that this code will work. And and then you just do whatever the interviewer suggests you to do. So now it's time to actually run the tests here. Very nice, and it passes all of these test cases that are given, including the third example, which we didn't go through. And that gives us enough confidence to submit this. And it passes. And in many coding interviews, you will find that there isn't really like a submit thing or anything. Typically what ends up happening is that you might have to write your own little test code, to test your function with different inputs and expected outputs, something of that nature, or come up with some edge cases for testing. All of that can happen. But yeah, so I hope that gave you a pretty good impression of how you can approach a code interview in a systematic way. I think it's fundamentally different than how you would approach maybe let's say a Leetcode contest or anything where it's really just speed counts and just shelling out a solution counts and not really explaining what you're doing. So in an interview, you want to always let the interviewer know what you're doing to keep them on board so that they can actually evaluate you. If you go silent or just put up perfect code but no explanation, that's going to be a poor score. So yeah, anyway, so that was the purpose of this video. I hope you found this one interesting, and maybe you can implement or find the final solution for the O of 1 time and space approach.